Hello, one. So we have another AMC problem. So this was a number 25. So which meant to be challenging. Let's see what we have. So we are told 1 inch squares are removed from each corner that has a 5 inch square. So this is 5 by 5. And we want to find the area of the square that is largest that we can fit into the remaining part. Okay. So like if you want to just kind of start with like this, you can just take these corners because that looks like we can connect these, which will make a 3 by 3 square because this is 1 unit, this is 1 unit, so 5 minus 2. So that means the area it will be 9, which is choice A. But if this is the case, it's kind of too simple. Like it shouldn't be that easy for the last problem. So instead of doing down, maybe we can draw a bit better than this, right? We can get larger one as well. So what I will try, I'm gonna take 1 point on each side and connect that to, so let me try again. Okay, so I'm gonna take this point and connect with this one. So if I try maybe best, I can go through this corner, which might be better as well. Okay, and then I'll do something like this. And then last one might be something like this. So again, it's not really accurate. So at this, it was telling us how things look like. But if I try my best, like this line actually gonna go through this corner, so I can do that because that is possible. So if I try my best to make a line that going touching the corner, so and then from a distance from this side and then going through the same way, like if I take this distance and just find that and then do the same thing with the other line because we have congruent figures. So it has to go through all these the corners. But I don't want to try one more time, but just assume this is kind of going through these corners, okay? So this is also going through this corner. Maybe I can try slightly better. So I'll say something like this. This may be not the best one, but again, so you got the point. So if I cannot do that, so it's fine. So something like this. So maybe I should have done this way, but anyway. So let's think about this is my corner. This is one corner. This is another. This is another. Okay. So, and our kind of not guess or assumption or not whatever is like this guy is gonna be square, but let me prove that first. So first things first, like I just say this is 1 unit. I'm gonna call this is X unit, whatever distance. So I'm just taking this distance exactly same from this corner. So that should be the same as well, which is X. And the same thing going on here. So this is also X. This is 1. This is 1. These are all ones. Okay. So then since like my drawing is not perfect, but at least it will be kind of possible. So we have angle right here is 90, and then this is also 90. So when you have like 90s, like this corner is also 90. I'll use different color. So if there, this is 90 degrees, this is 90, this is 90. Why this is important? Because when you have 90s, that means we have a lot of like similar triangles in most cases. But in this case, why do I care similar triangles? Because I want to find the area of this figure, which we do not know if this is square yet, but we'll see why this is the case. And then if we can find some similar triangles, that we can find the ratios and then get something we don't have. So that's why I just wanna kind of remember that. So I'll call this angle to be alpha and then this angle to be beta. So alpha and beta add up to 90 degrees. Since I draw these segments in a way that they are all congruent, then we know this red one is at least rhombus. And the angle that is opposite to 1 plus x, this is 1 plus x should be same on all because all these triangles are congruent since all three sides are equal. And then this is going to be alpha, same as this one. So that means this is beta. So which means alpha, beta add up to 90 degrees, right? So that means the angle right here, the angle right here is alpha and beta. This is beta, this is alpha. So that means this angle has to be 90 degrees because this is a straight line. The same story going on every side. So we do have these 90s then. Okay, so that means this is actually not just rhombus, this is a square, which is what we are trying to find the area of, right? So then here's what we are gonna do. Maybe I should draw something right here. So think about this is the triangle, like this one. And then I do have a smaller one, something like this. So these two are actually similar. So this is 1 plus x, which is 1 plus x. And then this is just x unit. And then this was also 1, so this is 1. And this side is, the entire thing is 5, so we got 1 and 1, 2, so which means the remaining has to be 3, but we said this is x, so it means this part should be 3 minus x. So from here to here. So if you add 1 to 3 minus x, so you will get 4 minus x for this. So now we know that these two triangles are similar because their angles are equal. So this angle is same as this one because that's the same corner. So we have 290s. That means we have two angles are also equal, at least equal. So that means the third one has to be. And now we can write the ratio. So that if I start with a smaller triangle, the ratio of the smaller, like one leg, I would say, divide by corresponding leg, 1 plus x, is equal to 1 over 4 minus x. So now I'll do cross multiplication. So if I do that, so I should be getting x times 4 minus x equals 1 times 1 plus x. Let's expand this. So 4x minus x squared equals 1 plus x. So I'm going to pull everything one side. So I'm going to add x squared to both sides. So if I add x squared to both sides, so we will get x squared on the right side. And then subtract 4x from both sides. So x minus 4 will be minus 3x. That will be on the one side. And then 1 is already on this side. So I'm going to pull that as it is, okay? So we have the x squared minus 3x and plus 1. So I just kind of simplify this one. But let's leave this one. But you can find the x if I want to by just solving the quadratic and stuff. But let's not try first if I don't need it. So what we need is the area of the red one. I'm gonna call each side is t. The largest square has area of 25. And then if I subtract area of the 4 triangles that is congruent, then I will get the area of what we want. So 4 times area of each one is like this is 1 plus x. And then the other side is 4 minus x. And then divided by 2. So let's simplify this. So this is 25. And then I can cancel this. So that should be 2. So let's expand this. So 1 and 4 is just 4. 1 minus x is minus x. X times 4 will be 4x. We are just falling. So x and negative x will be negative x squared. And that's what we are trying to simplify for. So 25. So you get negative 8. So we got like x, like 4x minus x, which is 3x. If you multiply this by, so you get minus, maybe I should just write 2 as a parenthesis after that. So I'm going to say negative 2 times 3x. And then this is like minus x squared. So the reason I did this because I have something right here is quite similar to this guy. So if I subtract 1 from this side, so you actually see the x squared minus 3x is equal to negative 1. But this is just the negation of this. We have negative x squared instead of positive. We have 3x instead of negative, which means this guy right here, the parenthesis, is equal to negative, like positive 1. So which means the answer should be 25 minus 8. Negative 2 times this will be negative 2. That's 10. If you subtract, we are end up getting 15. So again, it is quite challenging. Even though the question was less asking area of a square, it wasn't easy to find this side line immediately. So So we kind of had to use the similar triangles. So I hope that was clear. So if you kind of have somehow challenge like with this question, especially with similar triangles, you can review because even AMC 8 does have a lot of question about similar triangles. So anyway, I'll see you in the next video.